So, we want to answer a research question. The research design we choose determines if we can draw valid conclusions or not. Today, I'd like to talk you through a little flowchart that helps identify the most suitable design. First, we ask if we need to collect a new data set. Maybe data is already available that we can use, secondary data. If that's the case, that is very convenient because it saves us a lot of time and money. Still, we need to ask if our research question requires us to test for causality. Do we need to be able to say with confidence that A affects B, that A drives B, rather than merely being associated with B? We can draw causal conclusions from longitudinal secondary data with a critical incident occurring. Think of hotel bookings before COVID. Then COVID happens. Then we have hotel bookings after COVID. We can consider other factors such as exchange rates, weather, so we can isolate as much as possible the causal effect of COVID on hotel bookings. If we do not need to test for causality, the situation is even easier. We can use secondary data without any key critical events having occurred. When we need to collect new data, the key question is if our dependent variable is observable or latent. Observable variables can be seen, they can be measured. For example, we can measure how much food waste is left at the buffet. Latent variables cannot be seen or objectively measured. We have to ask people about them. For example, does a customer feel positive emotions about their purchase? If the dependent variable cannot be observed, we have no option but to ask people. We can ask them in an interview, in a focus group, or in a survey. Again, we need to check if our research question requires testing for causality. If not, we can collect one-off cross-sectional survey data. Like in election polls, we just want to know which political party people prefer today. If we do need to test for causality and the dependent variable cannot be observed, we run a survey experiment and we vary the value of the independent variable, that's the A, that we suspect affects the B. If the dependent variable is observable, asking people is suboptimal because people, for different reasons, are very bad at accurately reporting things that can be measured objectively. If you're interested in the temperature, why would you ask people to tell you how many degrees it was yesterday? Much better to use the measured, observed value as the dependent variable. Again, we need to determine if our research question requires the investigation of causality. If not, we can conduct a field observation. We can manually observe, for example, how people behave at a breakfast buffet. Or we can measure the temperature with a thermometer. If we do want to test if A affects an observable dependent variable B, we need to conduct a field experiment. This means we need to measure the baseline first, for example, the amount of uneaten food per person at the breakfast hotel buffet in grams. Then we introduce something, an intervention. For example, we reduce the plate size, and we measure if the amount of plate waste per person drops as a result of that change. And that completes our little decision-making chart. We hope you will find it useful.